everyone. This is Dr. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about definitions and terminology, Module 2. So, our Module 2 is probability distribution. So, contents. Definitions and terminology, question bank of probability distribution. This is our module 2. So, in our module 2 name is probability distribution. In probability distribution, we have 3 topics are there. So, first one is binomial distribution. So, second one is Poisson distribution. Third one is normal distribution. So, total in probability distribution, we have 3 topics. So, first one is binomial distribution, second one is Poisson distribution, and third one is normal distribution. So, before going to start a binomial, Poisson, normal distribution, definitions and terminology. So, now in probability distribution, we have 3 topics. So, first one is binomial distribution, second one is Poisson distribution, and third one is normal distribution. So, now we will discuss about first definition. Express the formula of variance of the binomial distribution. The variance of the binomial distribution is NPQ. So, before that, I will tell you, so what is actually binomial distribution formula? So, the binomial distribution formula, P of x equal to x, so that is equal to NCX, P power x, Q power n minus x. So, here x is from 0 to n. So, this is our binomial distribution formula. So, based on this, we can find variance. So, what is variance? So, actually, by now we know that binomial distribution and Poisson distributions both are discrete probability distributions. And the normal distribution is continuous probability distribution. Okay, so before going to start the variance of the binomial distribution, so first of all, the variance formula. So, variance is always denoted with sigma square. So, that is equal to summation x square f of x minus mu square. Okay, so here f of x is nothing but p of x equal to x. Okay, so here f of x is NCX. According to the definition of binomial distribution, f of x equal to NCX, p power x, q power n minus x. Okay, and here x is from 0 to n. So, by using these values or this formula, we can find the binomial distribution, variance of the binomial distribution, mu square, and x is from 0 to n. So, by using this formula, we can derive the variance of the binomial distribution. So, here the variance of the binomial distribution is NPQ. So, next one is describe the binomial distribution. So, what is the definition of binomial distribution? So, consider a random experiment having n trials, small n trials, let it succeed x times. Then the probability of getting x successes is p power x. That is nothing but probability of getting x success means p into p and so on p up to x times. So, is called as p power x. Okay. Next, the probability of getting n minus x failures. So, that means q into q up to q n minus x times. Okay. So, q into and so on n minus x times. So, this is called as q power n minus x. So, therefore, the probability of getting x successes out of n trials is binomial distribution b of x comma n comma p, that is equal to p of x equal to x equal to small x. So, that is equal to NCX, p power x, q power n minus x, where x is from 0 to n, that means 0, 1, 2, and so on n. Next, third definition. describe the Poisson distribution. So what is the definition of Poisson distribution? The Poisson distribution definition is here. Here x is a random variable, or a random variable x is said to follow a Poisson distribution if it assumes only non-negative values and its probability mass function is given by. So we know that the binomial distribution and the Poisson distributions both are discrete probability distributions. Discrete probability distributions mean those two are probability mass functions. Okay, so and its probability mass function is given by f of x comma lambda, that is equal to p of x equal to x, capital X equal to small x, that is equal to e power minus lambda, lambda power x by x factorial. So this is our formula, Poisson distribution formula. So e power minus lambda, lambda power x by x factorial, and here x is from 0 to infinity. So because in Poisson distribution we have three conditions. So first condition is n tends to infinity. Second condition is p tends to 0, and the third condition is np equal to lambda. Okay, so here in the binomial distribution, what is the formula? So the formula is, the binomial distribution formula is p of x equal to x, that is equal to ncx p power x q power n minus x. So here x is from 0 to n. But here in Poisson distribution compared to binomial distribution, in the Poisson distribution we have n tends to infinity. One condition is there, so that is n tends to infinity. So coming to the Poisson distribution formula, so the Poisson distribution formula is p of x equal to x, that is equal to e power minus lambda, lambda power x by x factorial, where x is from 0 to infinity, because here n tends to infinity. So now coming to the next question, fourth question. So describe the normal distribution. If x is a continuous random variable, so already we have discussed now. So binomial distribution and Poisson distributions are discrete probability distributions where x is a discrete random variable. But the normal distribution is a continuous probability distribution. So that's why here x is continuous random variable. Okay, so if x is a continuous random variable and mu comma sigma square are any two parameters, then the normal distribution is given by n of mu comma sigma square equal to. So that is, I will write here clearly, n of mu comma sigma square equal to, that is p of x1 less than or equal to x less than or equal to x2, or p of capital X1 less than or equal to capital X less than or equal to capital X2, that is equal to 1 by sigma root 2 pi, so e power minus 1 by 2 x minus mu by sigma whole square, where so minus infinity less than x less than infinity, where minus infinity less than x less than infinity. Now next question is, fifth question is, describe the properties of normal curve. Describe the properties. So what are the properties are there in normal curve? So actually the normal curve is bell shaped and it is symmetric about x equal to mu and z equal to 0. The total area in the normal distribution is, normal curve is unity. Normal curve is unity. So I will show you the graph. So the graph is here. The normal curve is bell shaped. So this is our bell shaped curve. Okay. So the normal curve is bell shaped and it is symmetric about x equal to mu and z equal to 0. So and the total area is unity. So that means that is 1. So this is 0.5. Half of the area is here, 0.5. So these are the properties of normal curve. Okay, so next definition is, state the Bernoulli trial. Bernoulli trial. So it is a random experiment having only two possible outcomes. It is a random experiment having only two possible outcomes which are denoted by success and failure. For example, tossing a coin. Tossing a coin. So this is a random experiment. So in tossing a coin, we'll get head and tail, right? So head, tail. So here I'm assuming that equal to getting getting ahead. So here I am assume that here I am taking the event as getting ahead. So that means here getting ahead means this is success. That means that is probability of success. Okay. So getting a tail, that is nothing but not a head, right? Getting a tail means not a head. So that means that is probability of failure. Okay. So here I am considering that, here I am taking that the probability of success is denoted with small p and the probability of failure is denoted with small q. So therefore, from that we can write p plus q equal to 1. So that means the probability of success plus probability of failure is always equal to 1. The probability of success plus the probability of failure is always equal to 1. So what is Bernoulli trial? It is a random experiment having only two possible outcomes. Those possible outcomes are success and failure. So coming to the next question. State the mean of the normal distribution. So what is the mean of the normal distribution? The mean of the, state the mean of the binomial distribution. The mean of the binomial distribution is NP. How we can derive this NP? So here N is nothing but number of trials and P is nothing but probability of success. So how can we derive the mean of the normal binomial distribution? So actually the binomial distribution formula is P of x equal to x, that is equal to NCx p power x q power n minus x, where x is from 0 to n. Okay, so we know that p of x equal to x is nothing but f of x. Okay, so according to mean, so mean in probability mass function, because binomial distribution and Poisson distributions both are discrete probability distributions, that is nothing but probability mass functions. So that's why here mean will be in summation x into f of x. So here x is from 0 to n. Okay, so by using this formula, that means summation x equal to 0 to n, x into what is f of x in binomial distribution, the formula is ncx p power x q power n minus x. So after derivation, we will get mean of the binomial distribution. So the mean of the binomial distribution is NP. Okay, so go through our previous video. So derivation of mean of the binomial distribution. Next question. State the variance of the Poisson distribution. So what is variance of the Poisson distribution? The variance of the Poisson distribution is lambda. So how we can solve? So according to the definition of Poisson distribution, the Poisson distribution formula is p of x equal to x, that is equal to e power minus lambda, lambda power x by x factorial, and here x is from 0 to infinity. Okay, so in Poisson distribution, x is from 0 to infinity. So what is variance formula? So actually the variance formula is summation x square f of x minus mu square. So here x is from 0 to infinity. So what is f of x? We know that x equal to 0 to infinity, x square into f of x is here e power minus lambda, lambda power x by x factorial minus mu square. Okay, so this is our variance formula. By using this variance formula, we can solve the variance of the, we can derive the variance of the Poisson distribution, that is nothing but lambda. Okay, so already we have derived this variance of the Poisson distribution in theory. Okay, you can go through that video. Next, state the mode of the binomial distribution. So what is actually mode? So what is mode definition? So mode is the value of x. Actually mode definition is, mode is the value of x for which f of x is maximum. For which f of x is maximum. So this is our mode formula. But mode of the binomial distribution. So mode of the binomial distribution is n plus 1 into p. If it is an integer. If it is an integer. So integral part of n plus 1 into p. If it is not an integer. So this is our mode formula, mode of the binomial distribution. So next one is state the mean of the Poisson distribution. So this is the mean of the Poisson distribution is lambda. So the Poisson distribution formula is this one. And here x values are x is from 0 to infinity. P of x equal to x, that is equal to e power minus lambda, lambda power x by x factorial, and x is from 0 to infinity. So but what is mean here? So mean. So because binomial distribution and Poisson distributions are discrete probability distributions are Poisson probability mass functions. That's why we have to use here summation x into f of x. So this is our actual mean formula. So if I substitute Poisson distribution formula there, we will get lambda. So that is here the Poisson distribution of the mean of the Poisson distribution is here lambda. Next definition. State the median of the normal distribution. State the median of the normal distribution. So what is median of the normal distribution? So actually the normal distribution is continuous probability distribution. Probability density function, that is. Okay, so here the formula is n of mu comma sigma square equal to, that is nothing but f of x equal to, so that is e power minus 1 by sigma root 2 pi, so e power minus 1 by 2 x minus mu by sigma whole square. So actual formula is this one. So what is, but we need median now. So what is median formula? So median of the median is, actual median formula is here a to m f of x dx equal to 1 by 2. So by using r minus infinity to m, in this case we have to use minus infinity to m, f of x dx equal to 1 by 2, or we can use m to infinity f of x dx equal to 1 by 2. So by using this formula we can derive the median of the normal distribution. The median of the normal distribution is mu. So next one is state the mode of the Poisson distribution. So mode of the Poisson distribution. Mode is the value of x for which f of x is maximum, and here mode equal to, mode of the Poisson distribution is lambda if it is an integer. If it is an integer. If it is an integer. And integral part of lambda if it is not an integer. Not an integer. So next one is, so coming to the next definition, state the mean of the normal distribution. The mean of the normal distribution is also mu. Mean of the normal distribution is also mu. So actually the the normal distribution formula is f of x equal to 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. So mean, it is a continuous probability distribution now. So that's why mean mu equal to here integration over minus infinity to infinity x into f of x dx. Okay, by using this formula we can find the mean of the normal distribution. The mean of the normal distribution is here mu. Next, state the variance of the normal distribution. So the normal distribution formula is f of x equal to 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. So this is our formula actually. So but here in normal distribution x is a continuous probability distribution. So that's why here with the variance formula will be in the form of integration, that is nothing but sigma square equal to 1 by integration over minus infinity to infinity x square f of x dx minus mu square. So by using this formula we can derive the variance of the normal distribution, but here the variance of the normal distribution is sigma square. So like that, mode of the normal distribution. The mode of the normal distribution is also mu. So therefore in normal distribution, the conclusion is here, therefore in normal distribution mean equal to, median equal to mode. So that is nothing but mu. So this is our module 2, definitions and terminology. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.